This lesson is for Advanced Algebra Lesson 11.3 on factoring. I want to be real clear with students about the assignment itself. The book asks you to factor a certain type of way or over a certain set of numbers, like the real numbers or the integers or the whole numbers. And I'll talk about that at the very end, but for the most part, I just want students not to worry about the directions that are given in the book or which way they want you to factor. I want you just to simply factor all the questions and all the polynomials that are listed, and don't worry about all the different directions that they give you. Keep in mind that some polynomials cannot be factored, and I'll address that at the very end of the video. For the ones that can be factored, you want to look for a GCF first. Again, GCF stands for greatest common factor. If there is a GCF, go ahead and factor it out, and then whatever's left inside the parentheses, see if that can be factored any further. Whether or not you pull out a GCF, the next thing you'd want to do is look at the polynomial's size. How many terms does it have? If it's a binomial, then you want to check and see if it's a difference of squares problem. Difference of squares problems will be binomials with a minus in between the two terms, and you'll be able to take the square root of both terms and come up with some kind of an answer to factor it. When you do factor it, you'll end up with the square root of the first term at the beginning of each binomial, the square root of the second term at the end of each binomial, and then you'll do one binomial with a plus and one binomial with a minus. If your polynomial that you're trying to factor is a trinomial, the next thing you want to do is look at the leading coefficient. That's what the LC stands for here. If the leading coefficient is a 1, then you'll just use the x method to factor it. Grab the a times the c from your original polynomial. Just a quick review here. Usually trinomials look like this. So we're going to grab the a and the c, and we're going to multiply those together and put those at the top. Grab the b value, put that at the bottom, and you're looking for factors at the top that add up to the bottom. Product on the top, sum on the bottom. And then whatever two numbers you get, those are going to be how you'll create your answer. If the trinomial has a leading coefficient other than 1, it might be a special case. And in that situation, you would do the square root of the first term, square root of the second term. And then if the sign that you see after the first term is a plus, then you'll put a plus in your answer. If the sign after the first term is a minus, then you'll put a minus in your answer. And then you just verify that the middle term is created by taking the two pieces that you got, multiplied together, and doubled. If the leading coefficient is not a 1, it might be one that you would solve using the Xbox method, which I taught students earlier. If you decide not to recognize whether or not it's a special case, or if you don't know if it's a special case, you can always use Xbox method to go ahead and factor. You'll use the same X method as you did for linear combination, but then you'll have to do the box or the hashtag after it as well. So let's practice that with a few examples. On our first one here, it is a trinomial. There are no common factors that I can factor out, so I'm just going to go right into looking at its leading coefficient. Since it's a trinomial with a leading coefficient of 1, I'm just going to do the x to factor it. Top of the x is 6 times the invisible 1, so that's a 6. The bottom is a 5. Factors of 6 that add up to 5 are 3 and 2, or 2 and 3. So then your answer is going to be x plus 3, x plus 2. Keep in mind that if you had those flip-flopped and put the x plus 2 first and x plus 3 second, that would still indicate the same answer. Number 2, there is a common number that we can pull out from all three terms, and that's the number 3. They also all have the number or the letter x. So I'm going to pull out a 3x. Now this is the part that I'm going to say out loud in the video here, what you should be saying to yourself when you do these. 3x times what is 3x cubed? That of course is x squared. 3x times what is negative 33x squared? Negative 11x. 3x times what is 90x? Positive 30. Now we're going to go ahead and try to factor the part that I got inside the parentheses. I'm going to see if I can factor that further. When I factor that further, I see that it's a trinomial with a leading coefficient of 1 again. So I'm going to do my x. I'm trying to find factors of 30 that add up to negative 11. If you're unsure of your math facts here, you can go ahead and just make a quick list. 1 and 30, 2 and 15, 3 and 10, 4 doesn't go in evenly, but 5 and 6 do, and 5 and 6 add up to 11. But I want them to add up to negative 11, so I have to make sure that they're both negative. I knew that was going to be the case because whenever the b value is negative, the two factors are always going to be negative. So my final answer now is the 3x, which was the GCF, and then x minus 5 and x minus 6. Remember, you can always double check your answer by doing FOIL on your answer or the extended distributive property. You should get the original polynomial back when you're all done. And if you do, that means you did it right. On the next one, again, there is a GCF. I can tell right away because both numbers end in a 0. If both numbers end in a 0, you know that 10 is a common factor. And since this number is the number 10, that's the most that I can pull out number-wise. As far as the letters go, I've got x to the 4th and x to the 2nd, so I can pull out x to the 2nd. 10x squared times what is 10x to the 4th? X squared. 10x squared times what is negative 250x squared? Negative 25. Now I'm going to see if I can factor this any further. This is a binomial with a minus in between, so I can factor that using difference of squares. So the 10x squared, I'm just going to rewrite that. For difference of squares, you set up two sets of binomials, one with a plus, one with a minus. We do the square root of the first term, so that's x and x. Square root of 25, that's 5 and 5. And so then that's my final answer. What about a problem like the next one, where it's x squared minus 14, and we don't know a number times itself that equals 14? Let's go back to the one we just did, and let's modify it slightly. Isn't what we did simply that we did x plus square root of 25 and x minus square root of 25? The only difference was we knew that that was going to turn into a 5 and a 5. So that's actually my final answer there. So I'm going to get rid of that circle. There we go. So my final answer came from me doing the square root and the square root. So on the next one, I can utilize that same idea. First of all, if I was asked to factor using whole numbers, I would say not factorable. Can't do it. But if you're allowed to use real numbers, then you would factor it using the difference of squares method by doing a plus and a minus. The square root of x squared is just going to be x and x, and then I would simply do the square root of 14 and the square root of 14, just like I did the square root of 25 and the square root of 25 on the previous question. The only difference here is I don't know the square root of 14, so I'm just going to leave it that way. So what we would say here on this question is that it's only factorable when you use the real numbers as your options for your numbers. If they say factor using only the whole numbers or only the integers, then you're going to say it's not factorable because there is no number times itself that equals 14. If you're allowed to use real numbers, then you would go ahead and factor it like we did.